Hello friends, very good morning. Friends, in today's session, we are going to derive some important derivations on the keys. Friends, key is a machine element, a small rectangular piece of element which is used in conjunction with the shaft to connect a pulley to a shaft or a gear to a shaft or a flywheel to a shaft. So this key will have a rectangular section having width B, thickness H and length of the key is L. It has got a rectangular cross section. Generally, a tapered key will have a small tape along the length. Say it will be generally 1 in 100. And friends, here in the figure I have shown, we are going to have this first derivation. He says, from fundamentals, derive expression for torque transmitted by the key in shear and that in compression. So friends, in the figure I have shown here, you have a key of width B, thickness H, length L, where half the depth of the key or height of the key is inside this shaft, how other half is in the mating member. So here it has got a diameter d or radius d by 2 and it is transmitting a torque. Now he is asking us to find out the expression how much is the torque transmitted by the key when it is failing by shear and what is the torque transmitted in compression. So there are only two methods how the key fails. It could be by shear of the key or by the compression or crushing of the key. Friends, here, if empty is the torque that is being transmitted, so we will take one by one. First of all, we will consider the failure of the key in shear. So I will write down, if empty is the torque, then empty key in shear means torque transmitted in shear by the key is equal to the shear force, which I call it as Fs, the shear force, multiplied by the radius. So what is the shear force? See friends, this key at this junction, it has got a dimension B into L. That is, when it fails by shear, the key gets cut in this fashion. So half the key will move to the right and half the key to the left. So the area under shear will be the width of the key multiplied by the length. So I will write down here, this is equal to F shear is nothing but shear area or area under shear. Shear area under shear multiplied by the shear stress, I designate by tau and multiplied by R. R is equal to D by 2. Friends, in machine design or thermal engineering subjects, all engineers should be very good in the dimension analysis. For example, friends, if you see here, shear area, you can just say here shear area or area under shear is B into L, and this tau is the shear stress of the key. So area into stress will give you the load. So this is going to be, the shear area is B, the length of the key is L, the area under shear multiplied by tau. This is for the key and hence I designated by tau k multiplied by R, that is D by 2. Friends, if you simplify, the empty key in shear is going to be B L tau k D by 2. Friends, on the same lines, let us consider the failure of the key in crushing or compression. So on the same lines, we have got empty key in crushing or in compression is given by the formula F crushing, load under crushing multiplied by the diameter radius. So this is equal to area under crushing. What is the area that gets crushed? It is the depth of this key inside the shaft multiplied by the L. That is, crushing will be, the F will be area under crushing. Area under crushing multiplied by the crushing stress, which are designated as sigma C. So area into stress will give you the load Fc multiplied by the radius, that is d by 2. Friends, here area under crushing will be the area of the key which is in contact with the surface of the shaft, that is h by 2 multiplied by the L, the length of the key, multiplied by sigma C, the crushing stress. This is the load multiplied by d by 2. So friends, you can write down here empty key initial will be h by 2 L sigma C into d by 2. So this is the load and this is the radius. So torque will be in terms of Newton mm. So friends, we can write down finally that the torque transmitted, or the expression for torque transmitted by the key in shear, empty key in shear, is equal to B into L into tau k into d by 2, where B into L is the area, this is the shear stress for the key, and d by 2 is the radius. So on the same lines, empty key in crushing or compression is given by the formula h by 2 into L into sigma C multiplied by d by 2. Friends, these two equations are very important, and whenever you are designing a key, you need to know both the expression so that you will be able to work out any problem on this. Friends, thank you very much for watching my YouTube video. Thank you.